Alright, we're going to be going over the review for the factoring test that is on Thursday, so coming up. So let's go ahead. Directions for the first part say factor the following quadratics. If cannot be factored, write prime. So let's look at number 1. We got negative 2x squared minus 16x plus 40, and we want to factor this. Okay, so always start by checking if there's a GCF. We are going to have a GCF here that we're going to have to factor out. Because all of these have 2 in common. However, keep in mind the first term here is negative, so we are going to have to factor out a negative number. So let's factor out a negative 2. So negative 2, negative 2, negative 2 is going to come out. So that's going to leave us with x squared, negative over negative, plus 8x, and then minus 20. So at this point, what we want to factor is x squared plus 8x minus 20. So I'm going to go over here and I'm going to work on factoring that. Up in the top we have a times c, which is negative 20. In the bottom we have b, which is negative 8. I'm looking for 2 numbers that multiply to negative 20 and add to negative 8. That's going to be negative 10 and positive 2. Multiply these together and you get negative 20. Add these together, you get negative 8. Alright, so I'm going to use that to split up the middle term so I can factor by grouping. X squared minus 10x plus 2x minus 8. I'm going to group the first 2 terms and group the second 2 terms and take the GCF out of each of them. So the GCF for the first group here is just x. So I'm going to take out the x, leaving me with x minus 10. GCF for the second group here is positive 2. So I'm going to take out a positive 2, and I made a mistake here, it looks like. It's supposed to be 20, not 8. It's supposed to be 20. Okay, so I take out a 2, and I'm left with x minus 10. Now, I knew I had made a mistake because these two are supposed to be the same if I did this right. And they were about to be different, but I went back and fixed that. Now they're the same. So now that they're the same, I can take that out. That will be my first factor. And my second factor is just going to be what's left, which is x plus 2. All right, so the fully factored form, going back to the original problem, negative 2, x minus 10, and x plus 2. Okay, so this factors into x minus 10 and x plus 2. However, we had the GCF negative 2, so the fully factored form, negative 2 times x minus 10 times x plus 2 for number 1. Number 2, we have x squared minus 21x plus 110. All right, no GCF to factor out. First term is positive, everything's good. So in the top, a times c, which is positive 110. The bottom is b, which is negative 21. 2 numbers that add to negative 21 and multiply to 110 are negative 11 and negative 10. Adding these gives you negative 21. Multiplying these gives you 110. So I'm going to use that to split up the middle term here into negative 11x and negative 10x. And everything else stays the same. All right, I'm going to group these into groups of 2 and factor the GCF out of each of them. So the GCF of this first group here is x. They have an x in common. Factoring that out leaves me x minus 11. GCF of the second group is actually going to be negative because the first term is negative. It's actually a negative 10, so I'm going to factor out negative 10. Okay, factoring out a negative 10 from this would leave me with x, and factoring out a negative 10 from 110 leaves me with negative 11. And these two are the same, which is good, so that's going to be one of my factors. And what is left over, x minus 10, is going to be my other factor. So my fully factored form, x minus 11, times x minus 10 for number 2. Number 3, x squared plus 3x minus 12. A times c, which is negative 12, b, which is positive 3. They do not have a GCF, so I don't have to worry about that. The first term is positive, so everything's good there. two numbers that multiply to negative 12 and add to positive 3, these actually don't exist. Nothing multiplies to negative 12 and adds to positive 3. Okay, I mean 1 and 12 don't, 2 and 6 don't, and 3 and 4 don't, and those are the only options, so we don't have anything. This can't be factored because we can't find the numbers. So this is called prime. Okay, if it cannot be factored, we call it prime. Number 4, 3x squared minus 9x minus 12. All right, first term is positive, that's great. However, these do have a GCF, so I'm going to have to factor out the GCF, which for all three of these, the GCF is 3. So let's factor out the 3 from each of these. So 3 out of 3, x squared, minus 3x, minus 4. All right, and then I can factor the quadratic remaining in the parentheses, which is x squared minus 3x minus 4. All right, so I'm going to try to factor that into its two factors. Okay, so I know that this has two factors, so I'll go ahead and set them up, the 3 on the outside. So I'm going to factor this by splitting up the middle term. A times c is negative 4, b is negative 3. Two numbers that multiply to negative 4 and add to negative 3 are negative 4 and positive 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So I can split this into negative 4x and positive 1x like this. I can group these together and take the GCF out of each group. The GCF of the first group is x, so I'm factoring x out. Factoring x out of x squared leaves me with x. Factoring x out of 4x, negative 4x, leaves me negative 4. Now x and negative 4, x minus 4, these don't have a GCF. They don't have anything in common, so I'm going to have to factor out a 1, a positive 1, which leaves me with x minus 4. Okay, so now I know what my two factors are. My first factor is what they have in common, which is x minus 4. And my second factor is what I took out, which is x plus 1. So the factorization for our answer here, the 3 is a factor that we took out, that's the GCF. X minus 4 is a factor, and x plus 1 is a factor. So 3 times x minus 4 times x plus 1 for number 4. Number 5, we have 81x squared minus 49. First GCF, there's no GCF here. Now there's only two terms here, 81x squared and negative 49. Now these are perfect squares, and this is a difference of two perfect squares. So if I can figure out the difference of the two perfect squares, then I can figure out the factors because it's just the sum of them and the difference of them. So to get 81x squared, I would have to square 9x. 9 squared is 81, x squared is x squared. To get 49, I would have to square 7. 7 squared is 49. So the factorization would be the sum of these, 9x plus 7, and the difference of these, 9x minus 7. And that is the way that 81x squared minus 49 factors, 9x plus 7 and 9x minus 7. Number 6, we have 2x squared minus 5x plus 1. No GCF, first term's positive, so everything's great there. So I'm going to move on to a times c. A is positive 2. Sorry, a times c, 2 times 1 is positive 2. B is negative 5. Two numbers that add to negative 5 and multiply to positive 2. I don't think they exist because the only thing that multiplies to 2 is 2 and 1, and those cannot add up to 5. So this cannot be factored. In other words, this is prime. It cannot be factored. So let's move on. Number 7, we have 30x squared plus 5x minus 10. All right, as we can see, before we begin, these three do have a GCF in common. Okay, not sure why that happened. Let's try this again. My writing program has crashed. Okay, so where were we? We had number 7, which was 30x squared plus 5x minus 10. And we said that these three have a GCF in common because 5 can factor out of all of them. So I'm going to take the 5 out of them. Taking the 5 out of here leaves 6x squared. Taking the 5 out of here leaves 1x. And taking the 5 out of here leaves negative 2. So now at this point, I want to factor 6x squared plus x minus 2. It's going to factor into two separate factors, so I'm just going to go ahead and set up my answer here. And then I'm going to go over here and figure out what two factors it is. Now remember, 5 is also a factor because it's the GCF. All right, now I need to figure out how to split up this 1x. So I'll do that using a times c, 6 times negative 2, which is negative 12, and b, which is positive 1. Two numbers that multiply to negative 12 and add to positive 1 are positive 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. So I can split up positive x into positive 4x and negative 3x, and everything else will stay the same. Now I can factor these two by grouping, and I can factor these two by grouping, because and remember that 3x is negative, so the sign needs to stay in front of the negative 3x. Let's take the GCF out of each group. The GCF of the first group, 2 goes into 6 and 4, x goes into x and x squared. So 2x will come out of the first group, leaving us with 3x. 6 over 2 is 3, x squared over x is x, plus x over x is 1, 4 over 2 is 2, so 3x plus 2. The second group, negative 3x and negative 2 don't have anything in common, but I do need to factor something out, so I'll factor out a 1. However, the first term is negative, so I have to factor out a negative number, a negative 1. So let's factor out a negative 1. Factoring a negative out of 1 out of negative 3x leaves me with 3x. Factoring a negative 1 out of negative 2 leaves me with positive 2. Okay, so this is good. Both of these are the same. That means one of my factors is 3x plus 2. That's both of these. The other factor is what the GCFs were, in this case 2x minus 1. So the fully factored form of 30x squared plus 5x minus 10, 5 times 3x plus 2 times 2x minus 1. Those are our three factors. It's our fully factored form. Now numbers 8 through 11, we are actually solving. So we got to take this a step further. So if we look at number 8, x squared plus x minus 20 equals 0. So we need to factor this, but then we also need to solve it. So set it equal to 0. It's already equal to 0. Great. Factor it. No GCF, so we can just split this in two. So a times c is negative 20. B is positive 1. Multiplies to negative 20 and adds to positive 1 is positive 5 and negative 4. Now I'm trying to factor this. Okay, ignore the equals 0 for now. We're not concerned with it. So this factors into x squared. Well, the positive x can be split into positive 5x and negative 4x, which I can now factor this by grouping these together. The GCF will come out of the first group, so x, leaving me with x plus 5, and the GCF will come out of the second group. GCF here is negative 4, so I can take a negative 4 out of these two, leaving me with x plus 5, which is what I want these two to both be the same. Okay, so one of the factors is what they have in common, x plus 5, and the other factor is the GCFs that I took out, x minus 4. Now this is just factoring it, okay? I've only factored it, now I have to solve it. It's very easy to solve this once you have it factored. Just set factors to 0. Okay, so take each of your factors and set them to 0. So x plus 5 equals 0. That's one of my factors, and x minus 4 equals 0. Each one of these provides me with a solution. So solving the first factor, gives me a solution, x equals -5. Solving the second factor gives me a solution of 4. And those are my two solutions to problem number 8, -5 and +4. Number 9, 2x squared minus 9 equals 3x. Okay, now this is not in the correct form. It needs to be in standard form, ax squared plus bx plus c equal to 0. Well, the 3x is on the wrong side, so let's move it to the left side. Okay, and when we write it, let's put it in standard form. So 2x squared followed by -3x followed by -9 equal to 0. So what I want to factor here is this. There's no GCF, so nothing to take out. I know that it's going to factor into two factors. I just need to figure out what those two factors are. So I'm going to go over here and I'm going to try to figure out what those two factors are by doing a times c and b. So a times c is 2 times -9, which is -18, and b is -3. So I'm looking for two numbers that multiply to -18 and add to -3, which is -6 and +3. That's going to let me split up this -3x. So I got 2x squared minus 6x plus 3x minus 9. I'm going to take the GCF out of each of these. So the GCF for the first group here is 2x. If I take out 2x, I'm left with x minus 3. The GCF of the second group is +3. If I take out 3, I'm left with x minus 3. So I have my two factors. The first factor is what they have in common, x minus 3. The second factor is their GCFs, 2x plus 3. Well, now I've got it factored. I can solve it by setting the factors to 0. So x minus 3 equals 0, and 2x plus 3 equals 0. And I can just solve these for x. So one of my solutions is 3. The other solution, subtract 3, divide by 2. The other solution is -3/2. And those would be my two solutions to equation for number 9. 2x squared minus 9 equals 3x. Plugging in 3 would give you the same number on both sides, and plugging in -3/2 would give you the same number on both sides. Number 10, 2x squared plus 11x minus 6 equals 0. It's already set equal to 0. There is no GCF for these three, so I can just go ahead and factor it. I know it's going to factor into two factors, so I'll just set those up. I'll go over here and try to figure out what those two factors are. So a times c, b. A times c, 2 times -6 is -12. b is +11. So numbers that multiply to -12 and add to 11 are +12 and -1. Multiplying these gives -12, adding these gives +11. So I can use that to split this middle term into +12x and -1x, or just minus x. And then -6. All right, now I'm going to factor the GCF out of each group. The GCF of the first group is 2x. Factoring out a 2x leaves me with x plus 6. The GCF of the second group is -1. Factoring out, because of the first term is negative, I have to factor out a negative, but they don't have anything in common, so it's got to be a -1. Factoring out -1 leaves me with x plus 6. So now I can fill in my two factors. First one is going to be what they have in common, which is x plus 6. That can be factored out, and what I have left, 2x minus 1. Now at this point I can set factors to 0 to solve this. So x plus 6 equals 0, and 2x minus 1 equals 0. All right, so one of my solutions is -6, and then the other one, add 1, divide by 2. The other solution is 1/2. Those are my two solutions here for number 10. And then the last problem, number 11, 4x squared minus 9 equals 0. So this is set equal to 0. Good. There's no GCF for the terms. Good. So I need to factor 4x squared minus 9. Now, I can't split the middle term because there is no middle term. This is a pattern I need to be able to recognize to factor, and this is a difference of 2 squares. So the way that we do a difference of 2 squares is by figuring out what each of the squares is, and then by creating the factors, which are the sum of the squares and the difference. All right, so to get 4x squared, to get 4, 2 squared is 4. And to get x squared, I would square x. So 2x to the second power is 4x squared. And then for 9, I would have to square 3. 3 to the second power is 9. So my two factors, 2x plus 3 and 2x minus 3. So the way the factor 4x squared minus 9 is 2x plus 3 times 2x minus 3. I can now set these factors to 0 and figure out the solutions based on that. All right, so I got the first factor to 0, 2x plus 3 equals 0, and the second factor to 0, 2x minus 3 equals 0. Solving these will give me my solution, so minus 3 gives me 2x is equal to negative 3. Divide by 2, one of my solutions, negative 3 over 2. The other solution, add 3, so 2x equals 3. Divide by 2, so my other solution is 3 over 2. My two solutions to number 11, negative 3 over 2 and positive 3 over 2. All right, and those are all of the problems that we can expect. Those are all the types we can expect to see on the test.